Anyway. All right, I'm gonna go through this right here. This is sort of engine performance slash emissions. It's sort of like a double thing. And I'll give you all a little bit of perspective based on the stuff that I learned over the past 40-something years doing this stuff and where we all started out. Now, fuel injection back in the day, you know, the earliest widely produced fuel injection system that was just for the common man. I mean, you know, Chevrolet dabbled with it, you know, years before that, but as far as having fuel injection on a lot of different, on a car that just anybody and everybody might buy, the first one that I was aware of was the 1968. They put fuel injection on this top 3 Volkswagen Squareback. They had a little fastback like that too, and that's pretty much what it looked like. It said the engine was in the back. You open the hatch and you pull the top off, and down in here you had fuel injection. Now it was an interesting way that they did that. If you kind of you get a handle on that, understand it, you can understand today's fuel injection a little better. This is sort of what we're looking at right here. The brain box was over here. Somebody had said one time that you could take that brain box and you could buy any parts you needed from Radio Shack to replace the components in that brain box in those days, you know. I don't know if that's true or not, but I heard somebody say that. But you can basically see how you got there's a little tiny plenum chamber here, and it was feeding to both of the heads and everything, and this distributor is a little taller than a regular VW distributor, so they had some extra components in it. And of course you had your little fuel injectors there, and they used rubber hose coming from the fuel pump, and they had about 40 pounds of fuel pressure. And occasionally when those hoses got rotten, you know, they'd bust and start squirting gas everywhere. But there were similarities here. For example, you had trigger contacts in the distributor. Trigger contacts is a couple of sets of points underneath the breaker plate. Wasn't the ones that operated the ignition system. Those little points was the trigger for your brain box. Received the trigger from that. Nicholas! Alright, so the brain box is considered, you got the trigger for that, and so you can see that was like your crank system, although it's just triggered there. Auxiliary air regulator. The auxiliary air regulator, the job the auxiliary air regulator does is it gives you fast idle. That's what the job it does, and typically it had a little bimetal strip. Now what bimetal is it's 2 pieces of metal that are married together, and one of them expands at a greater rate than the other one. Whenever you heat it up, it changes shape. The older gauges used to have a piece of bimetal in there, and there was a little wire wrapped around that piece of bimetal, and the more ground the sensor gave it, the more it would heat that little bimetal up, and it would move over, and the gauge would go over. Well, on these, that right there, that little strip right there, usually you got a spiral spring on these. I got another one of these somewhere that I thought was littler than this. Came off a Nissan. But anyway, that little spiral spring on the end of this is bimetal. If you heat that up with your cigarette lighter or torch or whatever, you'll see it change shape. But when it cools off, it goes back to its original shape. It has a memory. So when it's cool, it's one shape. When it's hot, it's another shape. And they tend to use that kind of thing for that. I wish I could see that other one. That other one I like better. But anyway, the spiral spring in that one, the reason that bimetal's there is it actually changes the valving inside that fan clutch, and it makes the fan more closely match the speed of the pulley that's driving it. Anyway, auxiliary air regulator had a bimetal in it, and whenever it warmed up, you know, basically it would heat up over time, and it would close off a passage. It was letting extra air go around the throttle plate. You also had a pressure sensor right here. You know, color that map sensor. And for the most part, there's a little legend down here. You can see all that stuff was laid out and everything. Temperature switch. That's a switch, not a sensor. So whenever it came to a certain temperature, it would close. It's like, contact switch on that. The change in electronics, the rise of the vane airflow sensor. Whenever this thing moved through, the air moved through here, it would move that vane, and that vane was hooked to a potentiometer that worked kind of like a TP sensor. So that's the way that measured. That stayed around for a pretty good while. Switches were replaced by sensors, and airflow became the primary modifier instead of, manifold pressure. Or, over here, you can look on here, you still got your ECU, and there's a fuel pump. You can see that's real familiar right there. It's going through the filter, and then there's your little fuel pressure regulator, and this is going. And also you have in this, that's a cold start injector, number 8. And that, you remember we talked about wetting the manifold? Like when we started this one up, how it double pumps the injectors until it gets to a certain speed, and then it starts firing sequentially. You see that? The reason that they needed a cold start injector on that was to wet the manifold so it would fire up. And so you can basically see the way that all this, the auxiliary air device, that one's got one of those on it too, you know, bypasses the throttle plate. You notice how it's piped? That auxiliary air regulator takes air and goes around this throttle plate. And of course the throttle plate's hooked to a throttle position sensor and all that. Now later on, Bosch came out with a different kind of fuel injection. They used mechanical fuel injectors, which were little atomizers about that long. You just screw the line onto them, a braided steel line going to them. And they just snapped into a little thing in the head. They had a big fat O-ring on them. You just popped them in there. And whenever you were, you know, this fuel distributor right here, heck, I guess they cut those little slits in that thing in the middle with lasers. I don't know what else they could cut them. And if you ever took one of those fuel regulators apart, you would never be able to get it back together without leaking where it worked right and all. I mean, they practically built that in a laboratory, I think, or, you know. But one way or another, that plate right there would be pushed up by the air. See, the air would come in, see that plate can move. So the airflow comes in on the way, and as it raises this up, that's sitting on that, and it would raise this up and it would increase the amount of fuel going to this little atomizer fuel injector. And all that. And so those fuel injectors didn't have wires going to them, they just had additional pressure and they would mist that fuel out there. Now the interesting thing there, later on you had your K-Jetronic systems. That was the K-Jetronic I just showed you. But it got a lambda sensor and a frequency valve so it could change the air fuel mix. And we had to take an exhaust gas analyzer and put it on a special little port on the exhaust and turn a little adjustment screw so we, on the one of the sensors, so we could get a, I don't remember which vehicle it was. We wanted 1% CO, which is, you know, pretty good bit, but the CO, emission standards allowed more CO then than they do now, you know. Anyway, so talking points. Engines may change, but they all need the same basic elements. An engine is an engine is an engine, right? It's going to have to have the same stuff. Engine controls may change, but they all need the same basic information. They need to know how fast the engine's spinning. They need to know the position of the, you know, whether each piston, which pistons are on, compression and exhaust and all that, especially if it's a sequential system where the fire in order followed by the injector. Engine control module needs to know engine speed, manifold pressure, or airflow, and throttle action. Those are the basic things. All that. Now, basic principles don't change. The manifold's got to receive a fuel charge on first start. Got to wet the manifold. That's what we're doing on that. Older system used a cold start injector. Newer system double pulse injectors or use some other method during crank. Injector pulses must match the speed of the engine as the engine starts. So as the engine picks up speed, if you're listening to the injectors, it'll go click, 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 click. You know, as the engine runs faster, they click faster. Then there's extra shots between pulses that happen. Now the pulse width, how long the injector is open, is modified based on load, temperature, throttle movement, that kind of thing. And throttle movement adds additional squirts in between the regular pulses, the ones that I'm familiar with. Ignition time, it has to advance with engine speed unless the engine's loaded. If you bring the engine speed up, if you happen to have a timing light where you can watch the timing, and you bring the engine speed up and just hold it at a steady speed, the faster the engine turns, the fuel is only going to burn so fast. So the spark has got to happen sooner, so you got time for the, you know, for that amount of pressure to be applied to the top of that piston. And so what you basically have to do though, when you're in a load, it's going to retard the timing so you don't have pinging and detonation and that sort of thing. So if you're ever watching the timing, if you're just giving it the gas, or if you're driving down the road holding your speed at 55 miles an hour in high gear, you're going to see 50, 60 degrees before top dead center on your spark. But when you get into it, or if you're pulling a trailer or something, you'll see it drop back to like 10 or 12. Even though the engine may be running faster, if it's loaded, the timing advance can't, you know, timing can't be as advanced as much. All right, what did I do that for? I pushed the wrong button. All right, fuel supply's got to be more than adequate. This is the return fuel system. You got a fuel pump going through a fuel filter, wherever the fuel filter may be mounted. There's also a sock down in the tank. All right, goes in there, and the injectors are squirting out here. You got a fuel pressure regulator. This is a vacuum line right here. And so basically it seemed like they thought it was a big deal to engineers whenever they built those fuel pressure regulators with a vacuum line. You know, they were saying for every 1 inch of vacuum, you had, you know, a pound of, or 2 inches of vacuum give you a pound of pressure or something like that. So they basically wanted to keep the pressure differential between what was in the rail and what was in the manifold constant. So they would lower the pressure as vacuum increased. See what I mean? If you got a lot of pressure and vacuum, they're thinking enough to suck the fuel out of the injectors and screw up the mix. But you know, we found out a long time ago, you could unplug that vacuum line going to that regulator. Didn't make any real difference on the fuel trims or anything. If, for example, though, if you ever are looking at a fuel pressure regulator and you pull that vacuum hose off and you see fuel there in that hose, that regulator diaphragm is busted and you need to put a regulator on it. That's fairly common, more so than you'd think. Something else I've actually seen was when you're checking, usually they'll have a, if you don't have a place to tap into the fuel rail with a fuel pressure gauge, you'll disconnect your fuel filter and connect your gauge between the filter and that line. That's where you'll get your pressure. And I have seen some of those fuel pressure regulators, when one was running rich and puffing out black smoke, something that with the spring would get rusty or something on the inside if it was one of the older regulators. And I've actually been watching my pressure and have an intermittent rich running problem, and I can just tap on that and I see the pressure go from 40 to 100 pounds, you know, that kind of stuff. And oh, and here's a cool one. This lady had a Cadillac Escalade, and it was set up kind of like this. You would see the difference in the returnless fuel system. The regulator on that Cadillac Escalade was down inside the tank. And I may have mentioned this the other day. If I mentioned it the other day, you can hear it again. She was having, I sent her over to Cadillac because it was throwing network codes and she had a traction control problem on that Cadillac Escalade. Sent her over there to the Cadillac place. I said, oh, let me have a reflash on that or something, because we weren't really fooling with any of that at the time. We just pulled a code. She came back and she said, they said I need a fuel pump. I said, what, for a traction control light and network code? What's up with that? So she said, they said the fuel pressure was too high. So we checked the fuel pressure, it was 160 pounds. That regulator down inside the tank, this one here, I've got it shown right here, but down inside the tank, the regulator on the fuel pump, made on the fuel pump, was malfunctioning, and it had really high fuel pressure. And so I said, well, you do need a fuel pump, but I had no idea what that's got to do with traction control. So we put a fuel pump in there, and the fuel pressure went down to where it was supposed to be, and the traction control problem went away. Of course, a lot of the times the traction control will detorque the engine, you know, to keep it from spinning the wheels too. And so that was a strange one, you know, that I didn't. I always like to be able to assemble the problem in my mind. A plus B equals C. But that was not one. Anyway, pressure regulator regulates the pressure down here. Some of your Chryslers have got a pressure regulator right on coming out of the tank. Some of them got it down in here on the pump. There's your evaporative canister. The vapor's going in here, and then it gets pulled out in the engine of that. All right. Now, electronic returnless system is going to have a PCM and a module controlling how much current goes to the pump, and it'll have a sensor on the fuel rail. Now, you see how these things have evolved. You see that you start out like that. Next thing you know, they're wanting to get rid of the return and, you know, regulate it back in the tank. And then you basically are putting the PCM in control of fuel pressure. And if the ground that fed to that fuel pump, there was one that I was, knew about, where there was a shorted wire. The module is supposed to send a pulsing ground to the fuel pump, and it puts more of a ground to speed the pump up when it needs more pressure. There was a Mustang I knew about that they were having all kinds of problems with the pressure not being able to be controlled, and that wire down inside the gas tank was shorted out on the fuel pump bracket, and it was making it have really high fuel pressure. All right, fuel pulse versus fuel pressure. Chevy CSFI systems have got the fuel injectors in the spider center, and this is a little spider that they got in there. See these little poppets? Now, that thing's got to have 60 pounds of pressure. Now, this is sort of within a pound or two. If you get one of those, those Vortec engines where you can't even see the injectors, it's just got that big connector in the top, like this little white truck we got out here. That thing, if it's got 56 or 57 pounds of pressure, it may not start, or it may run like crap. And you may have to put a fuel pump in it to get it up to 61 pounds before it'll run right. It's a strange thing. You feel like 57 pounds would be enough, but these little poppets have got to have a certain amount of pressure to operate. The electronic fuel injector solenoid that drives those poppets is up in here. There's a little, and I'll show you one here. It's what it looks like. Each one of them has got its own. See that? See a little pins right there? So there's your injector, and then there's the poppet. There is a way that you can get rid of this. On my dad's pickup, he's got a 96 Chevy. We put one of these kits on there. You can buy these kits for about $350. It doesn't even change the way the engine looks, but it makes it operate a whole lot better, because it's basically got those wires going all the way down to the fuel injectors. They got little fuel injectors that'll fit right where the poppets went, and the engine controller can directly operate those injectors, and it turns it into something like more conventional fuel injection. When you put it back together with these new seals and everything, you can't even tell that it doesn't have the regular old poppets on it. Really slick. Matter of fact, they put those on at the Chevy place now. You might notice the fuel pressure regulator is down inside the manifold on that one. Doesn't even have a hose hooked to that. It just lets the manifold pressure change that pressure. Now CSFI systems have a crank sensor in the timing cover and a cam sync sensor in the distributor. They've got a distributor back in the back. You might even have seen those caps that are got those the plug wires pointing in opposite directions back there. I got some laying over there somewhere I can dig out. This one right here. The caps that look like what I'm talking about. Back in the back of the motor. And you might notice you got to actually trace those little things so you can tell where number 1 is and where number, you got to know which way to be pointing the rotor when you put that thing back in, you'll mess it up. The cam retard offset has got to be checked if problems arise or if the distributor's been removed and installed. So if you got one that's not quite running right, you go in there with a good scan tool, you go to cam retard offset, it ought to be close to 0 typically. Now there's some little caveats to that in some of the year models, I'll show you that in a minute. But I'm basically looking for whatever the cam retard offset is supposed to be based on what the literature will tell you. And most of the time now you just replace the distributor. Believe it or not, the distributor those things came with was made of plastic, a junky plastic distributor. And the one that they sell from the parts store now is machined aluminum, a really nice distributor. We put one of those on there, and I've seen them just totally fix the way a vehicle is running. You change out that distributor. But if somebody has to put an intake manifold gasket on it because it's leaking oil or something, and they pop that thing back down in there and it's one of the adjustable ones, and they don't get that cam retard offset right, suddenly the fuel economy goes to crap and everything else, and people can't figure out what's going on. You won't throw a code. You just have the cam retard offset set wrong. When the engine is above 1,000 RPM, the distributor is rotated, if it can be. Some of them won't let you rotate it because of the way it's made, till the cam retard offset is 0, and those specs are kind of tough to find. Now, so the distributor will be turned on until the cam retard offset reads 0, which is 8 to 16 degrees on 96 models and 5 to 17 on 97s, but the newer ones were all pretty much on 0. But unless you hacksaw them off, the distributor has yours on a hold down bolt, and that's the that cam retard. I just pull that thing up there. If it's got a lot of miles on it, good idea to just throw a new distributor in there and recheck it. But you got to make sure you put that distributor in right. Who's done the 350? Done the 350 over, when you put that distributor in, you got to put it in there just right. You can turn the distributor timing on the 350 because you're changing the relationship between the pole piece and the pickup coil. That's how you're setting the timing. You're also changing rotor alignment at the same time. On these, when you turn the distributor, all you're doing is setting rotor alignment and the cam sensor. And so it's really important to recognize it. Just because it's got a distributor doesn't mean that you can set the timing. Dodge trucks and Jeeps, the V8 Dodges, they have one too where you're supposed to put the scan tool on there and look at that and turn the distributor and set the thing. They don't call it cam retard offset, they call it something else, but I've done it. 4-liter straight 6 Jeeps, put the crank on 0, turn the cam synchronizer so you can put a straight pin through both. Now the crank on 0, top dead center number 1. You don't want to put it on 0 and find out their companion cylinder, which is 6, is on number 1. Is on compression. You want it to be compression, top dead center compression on number 1, and then you turn this. It's kind of like it goes in the same place the distributor did when the Jeeps had a distributor. You turn it, and there was a hole in this outside housing and a hole in that vane, and you got to, with this set on 0, if you turn that and line it up, and then I just put a piece of wire through there that's nice and straight. You can tighten that thing down, you got your cam sensor right. On a Jeep, you'll have strange stuff. If that cam sensor is a little out of adjustment, it may start dropping companion cylinders, like 1 and 6, 2 and 4. Or 3 and 4, or 2 and 5, or whatever. I've seen that happen too. What makes it worse is when you pull codes on one of those 4-liter Jeeps that's got a cam sensor out of adjustment, it will actually tell you you've got coil primary faults and crap like that. It won't even tell you the truth about what's going on. When you can put a scope on it, you can basically see that this is supposed to be lined up halfway between these this is the crank sensor up here, and this is the cam sensor. It's just got a 50% duty cycle, and this has got all the little pulses for the cam sensor. And it ought to be making it switch halfway between two of the top 4 traces. So if you're looking at it live with a scope, you can turn that thing and line this up like, you know, halfway in between there. I don't know if that's in a book anywhere that I've ever seen, but you know, if, a lot of the times you can compare a good one to one that's not working right and see what it's supposed to look like and make the problem vehicle look like the other one, and you know, look like the good one, then you'll get one fixed that way. All right, turning the distributor doesn't change the timing if it has a crank sensor. Keep that in mind. The only way you can change the timing on one, you know, by making an adjustment, is if you could move the crank sensor or change the relation of the wheel with it. Some of the escorts that people would put back together because they didn't have a press-on balancer, they just put that bolt on there, they just snug it up a little bit. Balancer's good and heavy, and it's got that little trigger wheel like this right here on there, and if it wallers out that keyway and moves back and forth, you'll see those things, you'll take off on one of these escorts like that little green one we got over there, it'll run terrible, then it'll run good, then it'll run bad, then it'll run good. Finding that's tricky too. But whenever you pull that bolt out that holds the balancer, if you see that keyway wallered out, sometimes you got to replace the crankshaft on one of them whenever it's wallered out and mess the crankshaft up. Anyway, it's really important on all these vehicles to tighten the balancer up like it's supposed to be so that you won't have any problem with the keyway. Even on like a V8 engine, you know, things got to be pulled up are really tight against that gear so that it won't shear that key. That's another problem. Just changing a rotor alignment, if you turn a distributor on one that's got a crank sensor, and you know, basically on the old EAT3 stuff, when I first ran into that in 1983 when I went to work at the Lincoln dealership, this is kind of the way that's wired out with the crank sensor going down there. And this reluctor wheel just had 4 spikes on it. Yeah, basically is what it was, and that crank sensor was down there. I told y'all the other day about one of these, and when it would run 5 minutes, it would cut up and buck and snort and all that kind of thing. And I found out one of these wires was pulled back before that connector was plugged together. Now on rotor alignment, this is on one of those Jeeps that's got a distributor which got a crank sensor, but you can basically move the distributor. Now those actually had a little thing where you could move a distributor too. You hacksaw that one off, you could adjust this. What you were supposed to do, you're supposed to put that thing on top dead center of compression, kind of like you were doing with the other cam sensor, have a distributor cap with a window cut in it, and that rotor needed to be just passing that number 1 post, because you want the firing window to be so that no matter where the timing is, it's always closer to number 1 than it is any other post. You can see how the post right before that one, if the thing with rotor alignment was out and the firing window winds up closer to the one behind it than that one, then you get it afloat going down the road when you're at high, 50 degrees top dead center, it's going to start jumping and hitting the one behind the one it's supposed to hit, and you're getting this, bucking and jumping and all that kind of stuff. And so basically checking that rotor alignment is really important. It ought to be just passing that number 1 firing post. You got to cut that distributor so you can see that. That's on the Jeeps now. That's not on anything else that I know about. All right, quick test. What is EGR and why is it necessary? Talked about this a little the other day. Anybody remember anything about EGR? What's EGR stand for? Come on. Y'all don't be slow. You say, well, if we keep quiet long enough, you'll just tell us, and then we won't have to remember this anymore. Exhaust gas recirculation. Nick, you knew that. All right. EGR doesn't flow at idle. EGR doesn't flow at wide open throttle. EGR doesn't flow on a cold engine. EGR cools the combustion chamber. Here's the exhaust. We're borrowing some exhaust. We're coming around here. We're putting it back into the intake stream. That's inert gas. It will not burn. You're not reburning. Some people will say you're reburning exhaust gas. Basically, you're putting it in there so this doesn't burn as hot, because above 2,500 degrees you make oxides of nitrogen. You don't want to do that. Remember this. As a matter of fact, for emissions class, a lot of times I'll give a verbal exam at the end, and you got to tell me this. What's EGR? Why do we need it? You know what I mean? Not a hard question if you know the answer. Quick test. What's PCV? Somebody tell me what that stands for. Remember that? Are y'all slow or what?
Maybe so many 3-letter words.
Yeah.
It's the football number.
Positive crankcase ventilation. The first time I ever heard those 3 letters, I asked my dad. I said, "What is PCV?" And he said, "Positive crankcase ventilation." Now that's not PVC. That's polyvinyl chloride. That's like pipe, PCV. When my dad told me positive crankcase ventilation, I never forgot that. and I was like 16 years old. You know what I mean? And of course, I didn't use drugs or smoke or drink and all that. And I also didn't have a phone screen I was looking at all the time, so I guess I can remember stuff better. That's what the PCV valve looks like. All right, PCV system. Basically, you're going to take this PCV valve here, and what you're going to do, it's got this stuff inside of it. You got a spring and a plunger and all, and you see how the vacuum is going to change the position of that tapered plunger so you get less and more as you need it. It's pretty smart how they do that. That's vacuum. And basically, you're pulling air out of the crankcase and you're processing it through the intake, but you're going to get some fresh air from your intake system. You're going to see that pulling it out of the air inlet tube because they need that air to be metered. You can take the oil filler cap off of one of these new vehicles, watching your fuel trims. You take the oil filler cap out, suddenly you got an unmetered air leak and fuel trim starts going crazy. Imagine what happened if you had a seal that was missing off the oil filler cap and you had fuel trims that were going wacky. See what I mean because of that? And keep that in mind. That's all it, and also you're steaming the water out of the oil and all of the other stuff that blow by. You know, if this is stopped up and that's stopped up and this can't breathe, you're going to blow every seal on the engine. You got to put a rear main, can gasket, valve cover gaskets. You see every seal on an engine leaking, you made a doggone sure make sure you got a vacuum. When you pull that off of there, you ought to hear a hurricane. I mean, that'll be sucking hard. If you pull it off and you ain't hardly got no vacuum there, or if you pull this off and you don't feel air, a gentle pull on that, you need to find out what that PCV system. You ever took a breather off of an old car and had oil in it? What in the world's that oil doing in a breather? It's because the PCV system's not working right. It needs a PCV valve. That PCV valve, they say you can shake it. If you can't hear it rattle, you need to put one on there. And if you're putting a PCV valve on it, put the right one on there. On these new ones that are calibrated so carefully, you put the wrong PCV valve on there, that'll throw the fuel trims out of kilter too. Make sure you get the one that fits that vehicle. Some PCV systems don't have a valve, they just got a small vacuum orifice like on these Jeeps. See that little bitty orifice? It ain't got no moving parts, it's just a little hole. Some of your Japanese cars used to do that. They just put a little vacuum coil on that thing, and you got your fresh air inlet that's coming from the air cleaner. Now I will tell you that these did not have a mass airflow sensor, so anyway, they still want to filter the air though. They get clean air out of the intake stream. If this is left off or disconnected or busted or something, that air is going to pull what in there? Dirt, dust, crap that you don't want in your motor. It's going to get in there and ruin it. What's evap and why is it necessary? This is emissions class. Get right or get left. Okay, you got it?
We left.
Huh?
So we left.
Non-enhanced only measures the evap system flow. That's OBD2 systems. Basically what you're doing is you're taking vapor out of the gas tank, storing it in the canister until the engine controller decides to get rid of that vapor. It's to keep hydrocarbons out of the atmosphere. You know, you don't want to be, even in California where they got stiff regulations, you know when you put your gas in your car, they have this accordion tube thing over it so that all the gas vapors are contained. Have you seen that?
Yes.
All right, they've also got an onboard vapor refueling recovery system built into the car so that these fumes were actually pulled in there while you're gassing it up. You know, that pressure pulled in there. It's a strange thing. Enhanced system can seal the canister vent and measure fuel tank integrity or the whole integrity. 20 thousandths leak is too much. NVL system measures how well the tank holds pressure after the engine's turned off. Chrysler systems use a leak detection pump. Now the first evap systems purged only when EGR was flowing. Okay, so EGR is flowing when? It doesn't flow at cold engine, it doesn't flow at wide open throttle, and it doesn't flow at idle. It only flows when you're cruising down the road. Okay, you got that? All right, so you had a purge vacuum signal. So this thing right here would only get vacuum whenever the, you know, it's usually piped in there with some valves. An EGR valve had a little thermal vacuum switch to keep it from working when it's cold. That purge vacuum signal opened up this purge line and it would pull that other. If somebody packed their gas and this vapor line carried liquid gas in there, whenever it went to purge, it would make it run rich, so you don't need that. See, this one here had a vent on the bottom instead of up on the top, like I drew that one. Vapor line from the tank would hook in there. This is the old one. Now let's see how it changed. All right, then they started putting this purge solenoid so the computer could control that. That actually preceded a bunch of other stuff, even OBD2 on some of them. The vent solenoid was there so it could close this off, and so it could actually open this, close that, put a little bit of pressure change here, and watch that pressure. When it closed it off, it shouldn't leak back up. And that way, if it leaks back up, it throws you a PO 443 code or whatever. And that's what it looks like here. There's your purge cylinder wave